Welcome to my YouTube channel. I'll be explaining how to find or determine the resultant of more than two vectors by the method of resolving vectors. In my previous video lessons, I explained what is meant by vector resolution, that is how to resolve a vector. We say it's a process of splitting a vector into as many components as possible, and that we identify two perpendicular directions, that is resolving a vector along the x-axis, which is called the x component of the vector, and then along the y-axis, which is called the y component of the vector. Now, to start with, suppose you are given this kind of a question, and the first thing you need to do is to quickly draw a free body diagram of this question. That is, before you attempt solving this question using the resolution of vectors method to find the resultant of this number of forces acting on this body, you need to draw the free body diagram. And what's a free body diagram? A free body diagram is a graphical or symbolic, or can also call it a vector diagram, that is used to show the relative magnitude and direction of all the forces that is acting upon that object. Recall we said that we use a line segment and an arrowhead to represent a vector, the length of the line proportional to the magnitude of the vector, and the arrow points in the direction the vector is acting. So what are the rules for drawing a free body diagram? The first thing you need to do is to draw a dot to represent the objects. And then the second rule is to draw a coordinate system and label the positive directions. You can even add the negative directions of the coordinate system as shown in this diagram. Then the next thing is to draw the contact forces. That is, you have to place all the forces that act on that object, and you must label them. And the forces must be pointing away from the object. And when you are done that, you are now set to start finding the resultant of the forces acting on the body. Okay, let's start with this particular question. We are to determine the resultant of this system of forces. Okay, so we've already drawn the free body diagram, and here you have the object at the origin, because this is a coordinate system. I have the x-axis and I have the y-axis, positive for x, positive y-axis, negative x-axis, and then negative y-axis. Now, three forces act on this body. The 6 Newton acting along the positive x direction, the 10 Newton force acting along the positive y direction, and then this force of 3 √2 Newton is acting at angle 45 degrees to the x direction, that is the negative x-axis. So we have to determine or find the resultant of all these forces acting on this object at point O. So I can use two methods. The first method I like to use here is to resolve the three forces into their two perpendicular components. Now, what you need to notice is that if a force, for instance, in this case, is acting directly along this horizontal axis, it has no vertical components. Its vertical component, let me call that Vy or Fy, is equal to 0. Now again, when the force acts along the y-axis, whether it is acting vertically upwards or acting vertically downwards, it has no horizontal component. Its horizontal component, Fx, is 0 if it's acting along the y-axis. The same thing applies if there's another force acting along the negative x-axis. The vertical component of that force is 0. Okay, so which means you are good to go with this. This has only this component. It does not have vertical component. And this 10 Newton force has only the vertical component. It has no horizontal component. I can resolve these 3 √2 force. This will have both vertical and horizontal component. I can do something like this, try to make this up to a right angle triangle. So that this is my fx component acting along this line. What's my fy component? What's my fx? So using my SOHCAHTOA, my fy component opposite, this is my opposite. Of course, this side is the same thing as what I have here. So that I have my sine 45 is equal to opposite, which is Fy. Of course, recall that this is the right angle, so that this is the adjacent side, opposite and hypotenuse. That's Fy over 3 root 2. So that sine 45 is 1 over root 2 is equal to Fy over 3 root 2. So that if you cross multiply, Fy equals that's root 2 times Fy equals 3 root 2. So root 2 cancels out root 2. My force Fy is equal to 3. Now, to find the fx component, I'll use my cosine component. Cos 45 gives me my adjacent, that is fx over hypotenuse, that is 3 root 2. Cos 45 is also 1 over root 2. That gives me fx over 3 root 2. Okay, so this root 2 can cancel out this root 2 when you cross multiply. So that my fx is also equal to 3 Newton. So fx is 3 Newton and fy is also 3 Newton. I can redraw this diagram so that indicating the forces acting. I have here 6 Newton. That is what is given here. I have the 10 Newton force acting vertically upwards. That is it here. Then my result force, 3 root 2 Newton. The components are, I have the 3 Newton here. This is my Fy component. And my Fx component, I got 3 Newton. So this is what we need to do to show the picture after I have resolved this force 3 root 2 Newton into its x component and its y component. So I can still redraw the diagram and label all the forces now acting on the body at point O. So that if I resolve, finally, resolving vertically, I can assign positive. Of course, I've showed you already that any force acting along the positive y-axis, of course, is taken as positive. Then any force acting below the x-axis, that is along the negative y-axis, is taken as negative. So this 3 is negative. So my resolving vertically, the resultant force is 7 Newton. And then resolving horizontally, I have the positive direction of x is this, and this gives the negative direction of x. That gives me 6 minus 3. That gives me 3 Newton. So that the entire diagram can still be broken down to something like this. My 3 Newton force is acting horizontally, and my 7 Newton force is acting vertically. So that eventually the resultant of the two forces, 7 and 3, becomes the diagonal of this rectangle drawn from the common point of action, point O, where the object is. There I can use Pythagoras theorem. The resultant squared is now finally 7 squared plus 3 squared. That gives me square root of 49 plus 9. That is the square root of 58. The square root of 58 gives me 7.6. Approximately to the nearest one decimal place, I have 7.6 Newton as the resultant vector. Now to find the direction is this angle here. I will call it alpha to denote the direction. So we can take tan alpha gives me, this is still 7 because this side is equal to and parallel to this. So this is 7, this is 7. So opposite 7 over adjacent 3. So that this is now alpha equals tan inverse of 7 over 3. So for my machine here, I want to find the tan inverse of 7 over 3. tan inverse of 7 over 3 gives me my answer as 66.8 degrees. So that is the direction 66.8 degrees. That is the direction of the resultant vector. The next video, I'm going to take another question to find the resultant again of more than two forces.